With a new generation of Ethernet-APL products due to hit the process automation marketplace yet this year, process industries will finally be able to boast a unified Ethernet architecture that reaches from intrinsically safe field devices all the way to the cloud. Sure, device bandwidth will be much faster, allowing ready access to process variables as well as all that secondary data. But Ethernet-APL will also deliver substantially more electrical power to those devices, allowing more memory, more powerful microprocessors, and really unprecedented capabilities to the digital field. Hello, my name is Keith Larson, editor of Control Magazine and ControlGlobal.com, and you're listening to a Solution Spotlight edition of our Control Amplified podcast, sponsored this week by our friends at Emerson. To help explore what new field device capabilities Ethernet-APL will make possible, I'm happy to be joined by Jonas Berge, Senior Director of Applied Technology for Emerson's Automation Solutions business. Welcome, Jonas. Real pleasure to have you join us here today.
Thank you, Keith. Great to be here.
Well, thanks for taking the time. Maybe just to start things off, perhaps you can talk a little bit more about just how much more bandwidth and power we're talking about with Ethernet-APL. I think people talk about the bandwidth and it's going to be faster, but I think compared to analog 4 to 20 milliamp hard or even field bus technology, there's a lot more power that's reaching the instruments as well.
Yeah. So let's start with the bandwidth numbers. So Ethernet-APL runs at 10 megabit per second, while HeartIP runs at 1.2 kilobit per second. So APL really is more than 8,000 times faster, and field bus runs at 31.25 kilobit per second. So APL is still more than 300 times faster than that. Mm-hmm. So APL will be able to carry lots more data, which enables more devices on a network. So for the power supply, I'm glad you brought this up because it's important, but often forgotten as we get all excited about bandwidth. Right? So Ethernet-APL provides not only communication, but also power of the same two wires, just like 4 to 20 milliamp HeartIP loop-powered and field bus bus power. So for two-wire loop-powered HeartIP devices, their power is limited by the 4 to 20 milliamp signal. They must be able to operate on less than 4 milliamps, which is not much, and it limits what type of devices can be two-wire loop-powered. Now, depending on the application, APL provides more than half a watt or more than 1 watt of power to a device, which is almost like 10 to 20 times that of 4 to 20 milliamp devices. So devices in the past, had to be, those that had to be separately powered, in the past, will in the future actually be powered over the same single pair of wires. No separate power cable needs to be pulled.
Yeah. So what sort of possibilities does this open up for existing devices? Can current devices from flow meters to DP or temperature transmitters, what kind of new things are possible with more power other than, obviously all the secondary variables that can come in over the APL signal, but are there other new kind of capabilities that we can power with this new technology?
Sure. Yeah. So, 4 milliamp, is sufficient, to loop power many of the familiar instrument types like pressure, temperature, level, and some flow transmitters like DP and vortex, as well as liquid analyzers like pH and conductivity. But 4 milliamp is not sufficient to loop power certain other types of flow meters like Coriolis, mass flow, and mag flow, for instance. So those today need separate power, at least for the larger sizes. But in the future, with APL, many of these device types, but not all, could be two-wire powered, thus simplifying installation. But even devices which already are two-wire powered today can benefit from more power provided by APL. More power means more powerful microprocessors, which enable more advanced signal processing, which benefits some measurement types, such as those based on radar and ultrasound, which become more accurate and more robust, with better signal processing. Yeah, more power also means faster measurement updates. And maybe also, for the type of instrumentation, such as transmitters and valve positioners we are familiar with, the greater bandwidth that you also get with APL, means a higher speed. So you can put more devices on a network than with traditional field bus and still get faster response time. So yeah, you don't need as many networks, as you did with field bus. It also gives you greater spare capacity and flexibility to later add more devices to a network, without having to re-engineer to add another network and junction box. That is, APL provides greater ability to accommodate changes late, in greenfield projects or even after startup, without extensive re-engineering. Such flexibility is critical to initial project execution and later, for plants to stay evergreen.
Absolutely. Maybe we can talk a little bit, dig into a little bit more about the types of capabilities that represents. Maybe Emerson, obviously known for its Coriolis meter, power and bandwidth, I think would allow it to be more sensitive, right? Because you can actually have more power to energize the sensor, to the tubes as they vibrate. Is that right?
Yeah. So that's, because the tubes need power, right? So that's why today they are, at least the larger sizes need a lot of power, right? So, so they have to be separately powered, to get that sensitivity and, and accuracy, right? But with APL, you can get that sufficient power, over the same two wires, So you can get two-wire devices, which are more accurate and up to larger sizes, and so on, thanks to APL. So this is a very good example of what you can do with APL, and the same thing for MagFlow, right? They also need to energize the flow tube there.
Yeah, that makes sense. What about in terms of devices that tend to have some kind of a spectrum capability, like a radar tank gauge, where you're dealing with a lot of data? I mean, that's kind of data that stays stranded in the transmitter nowadays. You're not seeing the spectrum of how the radar signal or other technologies or vibration type of instrumentation. Does this open up better abilities to measure processes or do diagnostics for those kind of instruments?
Absolutely. So for a radar level transmitter, more power means it can use, the frequency modulated continuous wave, or, FMCW sensing technology, instead of the simpler pulsed radar. So FMCW has greater temperature stability and is better at handling disturbing echoes, particularly in tall tanks. So FMCW does require, advanced signal processing, right? But with the power from APL, transmitters will be able to, provide faster updates rate than in the past. And you also benefit, from high bandwidth, is that, during the instrument commissioning, the radar commissioning, you don't have to wait, for the radar echo curve to kind of slowly load in your setup app, right? It comes instantly.
Yeah.
And it can actually stream live, like live video. So you can adjust the installation and see how the echo curve, dynamically changes accordingly, right? And and you can see disturbances from agitators inside the tank. So easier to commission.
Yeah. Wow. That sounds like that would definitely cut some startup time off of project for sure. Yeah.
And I think another good one is like gas analyzers, right? That might also be possible. Imagine, for instance, installing the gas analyzers in the field near the process sampling point. So with minimal sampling lines, instead of running APL back to the people that need the data, so instead you use APL to run the data back to the people, right? So this is a whole lot easier to build and maintain than constructing analyzer shelters and lay and maintain long sampling lines, the traditional way.
Yeah, that makes sense. Does it, we haven't really talked about some of the whole movement towards the industrial IoT or doing more diagnostics of process diagnostics as well as instrument diagnostics. Do you see a new wave of being able to handle those types of data loads, much larger data loads more easily?
Yeah, well, I mean, thanks to digital transformation, IoT, and Industry 4.0 and Fourth Industrial Revolution, right? There's a huge interest in equipment condition monitoring and analytics, right? And not just for the large critical turbo machinery, but, turbines and compressors already have vibration monitoring in some cases prediction, right? Which is very successful. But these online systems are very expensive, right? So plant now want to do that kind of condition monitoring on their second tier essential assets like pumps and fans and conveyors, etc. as well. But at lower cost, since it's less demanding application. So some of this is done by wireless transmitters, as you know, but for some assets, plants now deploy, asset monitors, which are edge devices sitting in the field, monitoring multiple assets. So today these use regular Ethernet with separate power, and they do help plants, to move to predictive maintenance for, a much greater portion of their equipment. But yeah, in the future, these could use APL, to be even easier to deploy.
Are there new types of instruments that maybe we're not used to envisioning in the process field that this opens up as well?
Well, let's think about, bear with me here for a minute. Okay, so let's think about Ethernet in the office, So it's not just connecting laptops and servers to the internet. Ethernet also connects printers and scanners, and in our office, the phones are on Ethernet, CCTV cameras are on Ethernet, the video wall display is on Ethernet, and I'm sure there's more, right? So
this GoToMeeting session that we're doing right now is up.
Exactly, So Ethernet is the single common infrastructure, right? And there are no separate phone lines anymore, no separate CCTV cabling and so on. A single Ethernet infrastructure instead, takes the place of maybe 5 separate infrastructures in the past, So Ethernet-APL can do the same for process area in the plant. So APL has potential to not only take the place of 4 to 20 milliamp infrastructure, but also, the RS-485 infrastructure, the video cabling infrastructure, and regular Ethernet infrastructure in the plant area, into a single common APL infrastructure instead of 5 dedicated infrastructure that we have today. So a dramatic simplification. So to answer your question, with that, for instance, so many plants, they want to be able to see foaming or pebble size or stratifications, in their process, right? So today they send field operators out, to check, peeping through an inspection window. In the future, they can just drop in an APL video camera. I'm not talking about, your perimeter CCTV here, that will continue to use regular Ethernet. But, I'm talking about video playing a more important role in the process area in the future. So you could easily drop in an APL HMI panel, for instance, and if that would help you in certain tasks. And perhaps we will see LIDAR in process applications. So some of these things are theoretically possible today. You just need to lay 100 meters or a few hundred meters of Ethernet fiber, right? And power for that one device, So it's just too costly for a single use case. So it doesn't get approved. But once you have APL in every corner of the plant, dropping in these cameras, HMI panels, LIDAR, asset monitors, flow meters and gas analyzers, becomes easy and low cost, paving the way for that continuous improvement.
That makes sense. I do think one of the neat things is that it accommodates multiple different protocols, since you're really only talking about the physical layer with APL. From a practical perspective, do you think, will there be being a very conservative industry, will there be an instinct to say, okay, we want just control on these segments, but there may be a separately segmented network over here for, say, electrical equipment running, maybe Profinet over there versus the HeartIP over for the instrumentation and control networks. What's your sense on that, or is there sufficient bandwidth that we probably wouldn't even worry about it? I'm just kind of curious what your take on that.
Well, there's plenty of bandwidth, right? And Ethernet-APL, supports IP, and with that, it enables multiple application protocols, like you say. So with APL, it's no longer Heart or Modbus or Profibus. It's really HeartIP and Modbus TCP and Profinet. Plus other protocols such as HTTPS for web browsing or RTSP for video, right? All on the same wire at the same time. And there will also be OPC UA to HMI panels and analyzers. But having said that, it's good engineering practice to have subnets and security zones, right? So
Yeah.
There will be a subnet for the electrical gear in that room, right? And most of the traffic on that subnet might be Profinet, like you say. But
Yeah.
it will not be purely a single protocol like in the bus days, right? There will also be HTTP and OPC UA.
Yeah.
And oh, by the way, like this kind of electrical gear might continue to use regular Ethernet since MCC is usually indoor, with short distances.
Well, that's true.
But yeah, APL instrumentation will most likely use HeartIP, but yeah, the subnets for instrumentation will also not just be a single protocol. Like there will be HTTP and OPC UA at the same time, right? The mix of devices and use cases, sharing the same infrastructure and the mix of software tapping into, to their data really necessitates a mix of protocols. So the benefit of Ethernet is really the shared infrastructure, and you can't do that without mixing protocol.
I think it's just it'll be just a kind of a mind shift required for people to take that in this environment, that they become used to in the office environment and at home, obviously, as well, to say, okay, it's going to work here too. So it might take a little time, but it makes sense.
Yeah. So in fact, you can apply the office analogy here too, right? The beauty of IP is that one protocol doesn't have to do everything, right? Because in the office and at home, right, we use HTTP for web browsing and FTP for file transfer and IMAP for mail. Each protocol is specialized for a particular function, and APL will be just like that.
Great. From an install base perspective, we've been talking a little bit or touching on the HeartIP, which is the global community of instrumentation technician engineers are certainly more comfortable with the HEART protocol when it comes to managing and communicating with smart instruments than other protocols that are. I mean, it seems like we're on the verge of some competing interests, I would say, at the protocol level for EthernetAPL, with people advocating for HeartIP, obviously, but also Ethernet, as well as OPC, perhaps going straight to OPC field level communications, and even EthernetIP, meaning the ODVA version of EthernetIP. What's your sense in how that's going to play out in terms of the landscape for protocols when it comes to especially the process instrumentation side of things, which is our bread and butter in the controls community?
Yeah. Well, I mean, the protocols can exist, right? So, but think about the mix of device signal types, right? So let's say right now you're planning to build a plant based on APL, let's say, and we will see APL in DCS and PLC very soon. So no problem, for the core process control of the main plant to go APL. Mm-hmm. But what about the safety system, the fire and gas system and the machinery protection? Mm-hmm. I think they will be slower to adopt APL. So for now, they have to use 4 to 20 milliamp hour devices. I also believe packet unit vendors, like boiler manufacturer, will take a while to adopt APL. So they will ship modules instrumented with 4 to 20 milliamp hour for now, right?
Yeah.
So like we discussed, APL makes more sense, for certain instrument types than others. So it'll be a while before everything is available in APL. And let's not forget, about, wireless sensors, right? So plants now use wireless sensors instead of portable testers for vibration and ultrasound leak test and ultrasound thickness for corrosion inspection and instead of temperature guns and so on. And plants also put in wireless sensors instead of mechanical pressure and temperature gauges, site level glasses and variable flow meters, etc. So these wireless sensors use wireless HEART, right? So clearly it becomes a lot easier to manage this mix of instrumentation if APL devices use HeartIP, right? Because HeartIP, 4 to 20 milliamp HEART, and wireless HEART, they're all HEART. They all work and look and feel the same way, right? So this makes the job of the instrument engineers and technicians so much easier. So because lots of functionality and terminology is common, right? So and oh, by the way, you can run HeartIP all the way to the cloud. We run HeartIP from wireless gateways in the plant to analytics in the cloud, without converting to intermediate protocols.
Yeah, that makes a lot of sense.
Maybe on another note, faster sampling time also means, faster control loops, which means better control, so faster response time also means, that approved APL devices could in the future be used for functional safety. So with digital, we can avoid, covert failures associated with analog signals. So high speed enables safety instrumented functions, fire and gas and machinery protection system that currently, are hardwired, can go digital. That is, so really all plant systems can go APL, not just the basic process control. So APL also means, many devices will have embedded web servers, so you can configure, diagnose, and otherwise, manage these devices from a regular web browser.
Yeah, and I think it's also clear that all those 4 to 20 milliamp heart devices aren't going away anytime soon. I mean, you look at the rate of new plant construction here certainly in the U.S. There's not a lot of new plants going up. So heart is probably going to be around or 4 to 20 milliamp heart, I should say, is going to be around for a matter of decades. So having some commonality of a mixed environment is certainly a selling point for using HeartIP in those situations as well as the wireless.
So what users should do, right, is that, they are constantly upgrading their DCS, right? You do that every couple of years. You upgrade your DCS, you upgrade your device management software, so make sure that you upgrade your DCS to support HeartIP, so that you can benefit from HeartIP in your existing DCS, because HeartIP is not just, for the APL devices. HeartIP, it can be used in heart multiplexers also that some plants have, and it's also used in wireless heart gateways, so you don't wait until you're building your next plant, upgrade to HeartIP in your existing plant, and many users actually have HeartIP already, but they don't even know it. It's just ticking away there in the background in all of their wireless heart gateways.
Yeah, it would make sense that plays a role in many of the kind of configurable I/O solutions that are out there as well, that are extracting heart data on a regular basis from those 4 to 20 milliamp signals already. So I would imagine in some DCSs that's in the background functioning as well. Yeah.
It is, and we're also seeing it, like in safety logic solvers and so on too. So HeartIP is out there. It's actually been around for more than 10 years, but it's a very well kept secret, really.
Any other recommendations for users who are or folks at engineering firms out there listening about how they should prepare their next their current systems or their next designs for this coming revolution, I should say?
I think the main thing, is keep in mind, that we are moving away, from a single protocol. That was bus type of thing. Now we're moving into multiple protocols. So make sure to use, the right application protocols, for the right application. So that could mean, like your motor controls might be using Profinet or Modbus TCP or OPC UA, while your instrumentation uses HeartIP. And with the modern DCS, that's not going to be any problem at all because they support all of these protocols. So no issue.
Well, it's going to be exciting to see how this new technology kind of transforms what's possible. We've been through a lot over these years where we both date back to field bus days or before field bus days. So it'll be interesting to see how things continue to change. There's certainly no lack of change in this what used to be somewhat sleepy industry, but boy, things are changing fast now, aren't they?
Yeah. So on that note, APL actually have two important things going for it. The first one being that with Fieldbus, everything was really connected very much in parallel, right? So, and some users might have experienced that, if noise makes its way in on the bus, you can't really know at which device it entered, so it made troubleshooting quite challenging. The beauty with APL is that the switch is really like it's a switch, right? So each device actually sits pretty much on its own network, or spur, if you will, right? And what happens is that if noise makes its way into one device, it only affects that device. It doesn't propagate to the other ones. Okay. So first of all, network becomes very robust, and secondly, it becomes very evident, where the noise is getting in. So it becomes easier to troubleshoot. So that's one great advantage of APL. The second one being is that, the FDI package, that device description file.
Yeah.
That was always a big headache to get that, right? But with APL devices, that can be stored on board devices and automatically uploaded into the system. So you don't have to search the web, to extract that right file, the right file for your particular device and model and version and all of that. So that's dramatically simplified. And oh, by the way, you can just upload the instruction manual from the device. That can also be on board the device. So perhaps the two biggest points there, we learned a lot from FieldBus, and we made APL better in this sense.
So instruments on EthernetAPL really hold the promise to have a higher level of self configuration and things like we take for granted now with, say, a printer at home or in the office. Instruments will be a lot more like that in terms of having a layer of self-recognition, and you don't have to go dig out the CD-ROM with the device driver and that sort of thing on these kind of things. So you really see that happening in the instrument realm as well. Yeah,
because that can now, it's shipped on the device, and thanks to the abundant bandwidth, the system uploaded and, it solves that type of problem.
Yeah. One of the things you were mentioning about diagnostics for, the noise levels on the different spurs, understand that some of the chip level manufacturers, they can actually tell, like if there's a fault in a wire, somewhere along this 1,000-meter length, they can actually pinpoint exactly where that fault is, within, a few meters of. So if you're having problems with that wiring, not only is it just a bad wire, but they can actually, really have good diagnostics around where that fault might be, which is another layer of diagnostic information that you may not have in traditional schemes.
Yeah, the silicon has come so far, and thanks to, even like network switches, for APL, they will have embedded web server just like they do for regular Ethernet and Wi-Fi, right? So so that's how you can access that type of diagnostics, right? So you will, in the future, you will be troubleshooting with a web browser, in not a test pen or a multimeter.
Yeah. Yeah, well, that makes a ton of sense. Any other last comments, Jonas? Really appreciate you taking the time. Any other things that our listeners should remember, keep in mind?
No. So the main thing is, design for multiple protocols, and make life easy for the people that are going to operate the plant, by using HeartIP.
That sounds great. Well, thanks so much, Jonas, for sharing your perspective with us today. It's really been thought-provoking and a real pleasure as always. Again, our guest today has been Jonas Berge, Senior Director of Applied Technology for Emerson. Thank you all listeners for tuning in, and thanks also to Emerson for sponsoring this episode. Once again, Jonas, thank you for joining us.
Thank you.
And I'm Keith Larson. You've been listening to a Control Amplified podcast. And if you've enjoyed this episode, you can subscribe at the iTunes Store and at Google Podcasts. Plus, you can find the full archive of past episodes online at controlglobal.com. Signing off until next time.